let's get started. Okay. Woo. So, we're talking about integration, but what it means graphically. So, this is basically what it means. If you have an integral with a function, so this is your function, okay, y is equal to x, you're integrating x. Integrating is just asking you, okay, what is the area under that graph? I know, crazy weird. So if we're integrating y is equal to x, we're integrating x right here from 0 to 4, that would mean that we need to find the area beneath the graph from 0 to 4. So this area right here is what we would need to find. So, okay, that's a triangle. The formula for a triangle is 1/2 base times height. So, okay, we have 1/2 in front. The base is going to be 4, and then the height is also going to be 4. So that turns into 8. So now if we check it with integration, we should get 8 as our answer because 8 is the area of this triangle here. So, okay, if we integrate this, that becomes 1/2 x squared from 0 to 4. If we plug in 4, it's going to be 1/2 4 squared minus 1/2 0 squared, which is just 0. That turns into 1/2 times 16, which equals 8. Isn't that neat? So, okay, we know that we did that right, but let's try another example. Okay, so this time we're integrating 2. So y is equal to 2 looks like this graph right here. And we're doing it from 0 to 4. So that means we're trying to solve for this area of the graph because it's from 0 to 4. And we're just taking the area that's underneath this function. Okay, so the area of a rectangle there is base times height. So our base is going to be 4, right? This is 4, and our height looks like it's going to be 2. So that equals 8. Oh my god, that was the same as the last problem. That was silly. Okay, so let's check it with integration. That turns into 2x, right? From 0 to 4. We plug in 4 minus 2 times 0, which is just 0. Oh my god, also equals 8. Pretty cool, check. The next thing that you need to know about this is that you can have negative areas if the function is below the x-axis. So in this case, we're integrating y is equal to -3 from 2 to 3. So that means we're looking at this little box right here because this is from, well, wait, hold on, let me move this so it looks a little bit nicer. Okay, this is from 2. So this is from 2 to 3. Okay, so it's this little rectangle here. And keep in mind, this is -3. So when we do base times height, so the base is just 1, right? So the base is 1, but the height is negative because this is at -3 right here. So 1 times -3 is going to be equal to -3. So we would expect this integral to equal -3. So when we try it out, that turns into -3x evaluated from, evaluated from 2 to 3. That should say 2 to 3. Okay, oops. Okay, so we plug in -3, then we plug in regular 3 because that's our top one. So it's -3 times regular 3 minus -3 plugging in 2 times 2. So that turns into -9 plus, because these two negatives make a plus, 6, which equals -3. Okay, done. So let's say this purple function is f of x, and we're integrating f of x from 0 to 5. Well, we don't actually have a function that we could integrate to see what it's going to be, so we have to do it graphically. So that means we just need to add up these two areas together and see what it is. So, okay, first let's find the area of this triangle. Well, the area of a triangle is 1/2 base times height. So we have 1/2, the base looks like it's 3, and the height looks like it's 4. So that's going to be equal to 1/2 times 12, which is just 6. So now we move on to this little square here. The area of a square is just base times height. So now be careful with this. The base, yeah, is 2, but the height is going to be -2 because this is negative. So that's going to be equal to -4. So our last step to solve for the integral of f of x is going to be to add these two together. So it's going to be -4 plus 6, which is equal to 2. So this is going to be your answer for this integral.